Ready for another deep dive? Today we're going to be talking about something really cool.
Yeah.
China's building their own space telescope. Like their answer to the James Webb.
Oh, yeah, it's pretty amazing.
I know. And get this, we're digging into all the details from this Live Science article. It's called,
Hang on, I've got it right here.
oh, perfect.
China is building a space telescope to rival the JWST, and it could survive in orbit decades longer.
That's the one. So we're going to figure out why everyone's making such a big deal about this new telescope and what it could mean,
For the future of space exploration.
Exactly. Space exploration and like the whole field of cosmology, right?
Absolutely. I mean, China's space program has been, they've been getting more and more ambitious.
Yeah.
And now they're taking on, the biggest questions about the universe with this China Space Station Telescope.
The CSST.
Yep, that's the one. Or Xuntian, if you want to use the Chinese name.
Which means,
Surveying the sky.
oh, wow, that's kind of poetic, isn't it? Like fitting for a space telescope.
Definitely. And the name really gets at what's so special about this telescope in Maine.
Go on.
Instead of just being, a one-time mission, the CSST is going to be orbiting with the Chinese space station.
The Tiangong, right.
Yeah, exactly. Which means they can actually send astronauts up to,
Fix it?
yeah,
Yeah.
fix it, upgrade it, keep it running for, potentially decades.
Wow, so it's not like those other space telescopes that are kind of like time capsules.
Right.
Stuck with whatever tech they had when they were launched. This one, the CSFT.
It's more like a living observatory,
Yeah.
It can evolve and adapt as our technology improves.
Okay, so we've got this seriously long-lasting high-tech space telescope. But what's it actually going to look at? Like, what are we hoping to learn from it?
Well, first off, it's got a massive mirror, 6.6 feet across.
Whoa, that's almost as big as the James Webb, isn't it?
Pretty close, yeah. But what's really wild is its field of view.
Yeah.
We're talking 300 times wider than Hubble.
Wait, 300 times? So what does that even mean practically? What will we be able to see?
I mean, imagine these huge panoramic views of the cosmos. You're seeing entire galaxies.
Like the whole thing?
Yeah, pretty much. And star-forming regions, those clouds of gas and dust.
Oh yeah, where new stars are born.
Exactly. And even things like supernova remnants, the leftovers from exploded stars.
So it's like taking those incredible space photos you see.
Like Hubble images.
Yeah, but cranking it up to 11.
Uh,
But it's more than just pretty pictures, right? We're talking serious science here.
oh, absolutely. One of the big goals is to map dark matter.
Okay, now dark matter is something I've always struggled with. Can you explain it like, I'm 5?
Okay, so imagine the universe is like this giant cosmic web, right? And galaxies are, beads strung along the threads.
Okay, I'm picturing it.
Now, this web is held together by something we can't see directly, something that makes up most of the universe's matter.
That's the dark matter.
That's the dark matter. It's kind of like the scaffolding holding everything together.
Whoa. So this telescope is going to let us actually see this invisible scaffolding.
Not see it directly, but map it out by looking at how light bends around dark matter.
Oh, right, like gravity.
Exactly. It's called weak gravitational lensing. And by studying how the light gets distorted, the CSST can create this incredibly detailed map of where the dark matter is.
Now that's what I call a deep dive. But this article also mentioned some other things I didn't quite get, like voids and clusters and...
Baryon acoustic oscillations.
Yeah, that one. Break those down for me.
Okay, so picture the universe as this, bubbly sea of galaxies. Some areas are really dense, with lots of galaxies clustered together.
Those are the clusters.
Right, and then there are these vast empty spaces between them.
The voids.
Exactly. By studying the voids and clusters, scientists can learn about dark energy.
Which is,
That's the mysterious force that's making the universe expand faster and faster.
So dark matter is like the scaffolding, and dark energy is like stretching the whole thing.
Kind of, yeah. Now, baryon acoustic oscillations, that's a mouthful, right?
Tell me about it.
It's basically about measuring these ancient sound waves from the very early universe.
Crown waves. In space.
Yeah. They left their imprint on the distribution of matter, and by studying these ripples, the CSST can help us understand how the universe has evolved over time.
Okay, so we've got dark matter, dark energy, ancient sound waves. This is starting to sound like a science fiction movie.
I know, right? But it's
Yeah.
all real. And the CSST is going to help us understand it all even better.
This is seriously blowing my mind. We've covered so much already.
I know, right?
And we're just getting started. Before the break, we were talking about the CSST mapping dark matter.
Right, like a cosmic cartographer.
Exactly. But it got me thinking, is it going to be working solo? Or will it, like, team up with other telescopes?
Oh, definitely not alone. There's a whole bunch of new telescopes coming online, and astronomers are already figuring out how to make them work together.
So, like, an Avengers team of telescopes.
Haha, kind of. You've got the Euclid telescope, which is going to focus on dark energy.
And the Nancy Grace Roman Space Telescope.
Yep. Right. Each one has its own strengths, but together they can create this much more complete picture of the universe.
Like, imagine if Euclid finds something really interesting. It could tell the CSST, hey, take a closer look at this.
Exactly. And because the CSST can be upgraded, it could even get new instruments specifically designed to follow up on those discoveries.
Wow, so it's not just collaboration, it's like evolving collaboration.
Yeah, it's pretty exciting. And it really shows how science can bring people together.
I mean, you've got scientists from all over the world working on these telescopes, sharing data.
It's like this global effort to understand the universe.
So cool. Okay, so we've covered the tech, the collaboration, but let's get into the really mind-blowing stuff. Like, what kind of discoveries are scientists hoping to make with the CSST?
Well, one thing that's got everyone buzzing is the possibility of seeing the very first stars.
Wait, like the first stars that ever existed?
Yeah, those are called population 3 stars. They formed right after the Big Bang, and they were massive.
Like, how massive are we talking?
Hundreds, maybe even thousands of times bigger than our sun.
Whoa, hold on. So our sun would be like a tiny speck compared to these things.
Pretty much. And these stars were the ones that created the first heavy elements, the stuff that makes up planets and, well, us.
So we're talking about seeing light from the very beginning of the universe.
Yeah, it's like looking back in time. And the CSST is designed to be able to detect that light.
Mind-blowing. But are there any other, I don't know, even crazier possibilities?
Oh, well, there's always the chance of finding evidence for a parallel universe.
Okay, now that sounds like something straight out of science fiction.
I know, right? But there are some theories that suggest our universe might be just one of many.
So, like, a multiverse.
Exactly. And some of those theories say that collisions between universes might leave traces in the cosmic microwave background radiation.
That's the afterglow of the Big Bang, right?
Yeah. And the CSST might be sensitive enough to detect those traces.
So we could actually find proof of another universe.
It's a long shot, but it's possible.
I mean, even if it doesn't find another universe, this telescope is going to make some incredible discoveries.
Oh, yeah, we're going to learn so much about the universe, about how it all began, how it works.
It's like we're on the verge of this whole new era of understanding.
Absolutely. And who knows what we'll find? It's what makes it so exciting.
I'm definitely feeling the excitement. But with all this talk about cosmic discoveries, I'm also wondering, what about us? Like, what does all this mean for humanity? So we've been on this incredible journey with the CSST.
I know, right? It's pretty mind-blowing.
Mapping dark matter, maybe even finding parallel universes.
It's wild stuff.
But it makes me wonder, like, how does all this cosmic stuff affect us down here on Earth?
That's a big question.
I know, right?
It goes beyond just science, It's about philosophy, about who we are.
Yeah.
I mean, for centuries, humans have looked up at the stars and asked those big questions.
Like, are we alone?
Exactly. How did it all begin? Where are we going?
And do you think the CSST could actually give us some answers?
I think it'll definitely get us closer. Every time we learn more about the universe, it changes our perspective.
Like, how so?
Well, imagine if we find proof that there's life on other planets.
Oh, wow. Yeah.
Or that our universe is just one of many.
A multiverse.
Yeah. Wouldn't that completely change how we see ourselves?
It would be huge.
Yeah.
I mean, think about religion, philosophy, history.
Everything.
Even if we don't find those definitive answers.
Yeah.
Just the act of searching, of pushing the boundaries of what we know, that's got to be important.
Oh, absolutely. It's what drives us forward as humans.
It's like that human curiosity that need to explore. It's led to so many incredible things.
Exactly. And think about all the technology that comes from these big scientific projects.
Like building these super advanced telescopes.
Yeah. It pushes the limits of engineering, optics, computing.
And those innovations end up benefiting everyone, right?
Absolutely. It's like a ripple effect.
Hmm.
We learn more about the universe, and we develop new technologies that can improve life here on Earth.
So it's not just about, like, satisfying our curiosity.
Right.
It's about investing in our future as a species.
Well said. And don't forget the inspiration factor.
Oh, yeah.
Imagine those first images from the CSST.
Like those stunning Hubble pictures.
Yeah, but even better, think about how those images will inspire people, especially kids.
Oh, totally. It's like seeing those pictures could spark a whole new generation of scientists and explorers.
Exactly. It's a beautiful cycle.
Curiosity, exploration, inspiration.
And the CSST is going to be a big part of that.
This whole deep dive has been amazing.
I know, right? So much to think about.
And we've only just scratched the surface of what this telescope could do.
It's truly remarkable what humans can achieve when we set our minds to something.
So, as we wrap things up, I want to leave everyone with this thought. Never stop being curious. Keep looking up at the stars. Keep asking those big questions.
Because out there, in the vastness of space, there are endless wonders waiting to be discovered.
And who knows what the future holds? Maybe the CSST will help us unlock some of the universe's biggest secrets.
I can't wait to find out.
Thanks for joining us on this deep dive. Until next time, keep exploring.